Section 2.8 Absolute Value Equations. In this section we're going to talk about equations that have absolute values in them. Okay, so before we do that, let's first talk about absolute values. So what is absolute value? Okay. Whenever we ask most students what absolute value is, the first definition they give back is they tell you it makes a number positive. And that is a good definition to begin with. It's a non-mathematical definition, but it's a good one to start. The geometric definitions of absolute value is it's the distance of a number from zero, distance of a number from zero on a number line. And whenever we talk about distances, distance is always positive. So in essence, you get a positive number back. Okay, so that's a geometric definition. If you think about it, here's my number line, here's 0, here is 4. So the absolute value of 4 would be this distance, which is 4 units, so it'll be 4. On the other hand, if I'm here, minus 1, it'll be the distance. Absolute value of minus 1 would be the distance from 0 to minus 1. That's this distance, which is 1 unit. Okay. So it's a distance of a number from 0 on a number line. But this is the definition we need, and this is the definition we'll use a couple different times in this class. It's a mathematical definition. Okay, which basically does what the above two definition do, but just do it rigorously using mathematics. Okay, so let's think about it. Absolute value is always denoted by two vertical bars. So if you take absolute value of some number a, where a is any number, okay, for example, a could be 5, a could be minus 1, and so on. Okay, so I want to find the absolute value of a. Now if you go back to the non-mathematical definition, what does it say? Absolute value makes a number positive. So let's think about that for a second. If this a was positive, let's assume a is positive. This number is positive. If this number is positive, do we even need absolute values? Because if the goal of absolute value is to make something positive, then the absolute values are an overkill here. We don't even need them. For example, let's say if I have absolute value of 5. Well, this number on the inside, this is a positive number, isn't this? So we don't even need these absolute value symbols anymore because the number is already positive, so we just get 5 back. We can write that without absolute values. Okay, so if the number is positive, absolute value is not those absolute value bars are not required. We just get that number back, a. If a is greater than 0, when we say something is positive, we say it's 0, and in this case it also applies if a is 0. Okay, so in essence it basically means positive. Okay, so remember, again, going back to the first non-mathematical definition, the goal of absolute value is to make something positive. So if you're taking absolute value of something that's already positive, then you absolutely do not need those absolute values. You can just drop them and you just can keep that number. Okay, and that's what we did over here. If a was positive, we just get that back. Now let's assume that a is negative. Okay, so we have, here's an example. Let's say if I have minus 9. So this number on the inside is like my a, and you can see it is negative. Okay, so my a is like a number that is negative 9 in this case. Now I want to take the absolute value of this. If you use the non-mathematical definition, it tells me what absolute value of minus 9 is. 9 is just a positive number. You just ignore the negative sign. Okay, but how does it go about doing that? How does it mathematically change from minus 9 to 9? There must be something happening in between for this number to go from here to here and just get rid of that negative sign. We can't just drop it. You have to actually justify it. So in this case, what happens is if the number inside the absolute values, inside these bars, is negative, okay, and we eventually want to make it positive, we have to somehow get rid of that negative sign. So the way we do that is, in math, the only way you can get rid of a negative sign is if you introduce another negative, right? Because negative times negative is what? If you have two negatives, become positive, okay? So that's what we want to do here. We want to introduce an extra negative so that around that number. Now I drop the absolute values and introduce that extra negative. Once I introduce that extra negative, two negatives will become positive. Okay, so if the number is negative to begin with inside the absolute values and you want to make it positive, just add another negative sign to that number, and that's how it becomes positive. So if out here in this definition, going back to this definition, if a is negative and I want to make it positive, I'm going to need an extra negative in front of a to make it positive. So if a is less than 0 means numbers are negative. So this is the mathematical definition of absolute value. Okay, so keep that definition in mind because that's what we're going to use today to solve absolute value equations. Okay, so anytime you want to write anything without absolute values, out here we have something with absolute values, I want to write it without absolute values, you need to know something about the number inside, whether it's positive or negative. If it's positive, you just get that number back. On the other hand, if it's negative, and since you want to make it positive, we have to introduce an extra negative to make it positive. Okay, so let me give you a couple more examples just to drive home that point. Okay, let's see if I have absolute value of minus 25. Okay, yes, the answer is 25. We know that because that's what absolute value does, gives you a positive number. But let's show the steps that we have to go through to get there. Since this number is negative and I want to make it positive, I'm going to have to introduce another negative. So you get negative 25. Then negative times negative is 25. Okay, so that's what this definition tells us. Introduce that extra negative to make the number positive. So if a was already negative, then you need another negative in the front to make that expression positive. Okay, so now that is positive. Alright, the best way to know if you understood the definition of absolute value is to understand these examples. So let's say I want to write the following expressions without absolute values. Now before I give you those examples, let me go back again. I know I've repeated myself. If you want to write anything without these vertical absolute value bars, you always have to know what this is, whether this is positive or negative. Depending upon what it is, you can write it appropriately. Do you see there's no absolute values on this side here? Because we've already made sure that this the number always we get back from absolute value is positive by making certain corrections. Out here, if it was positive, we just get positive. If it was negative, we threw in another negative to make it positive. So we didn't need those absolute values anymore. Okay. Alright, so let's say if I have this, if I give you the simple expression, I tell you x minus 3 if x is less than 1. Okay, so I want to write this expression that's given to me. I want to write it without absolute values. Okay, so I don't want these vertical bars anymore. Well, the only way I can drop those vertical bars is if I know whether the inside is positive or negative, because I'll have to use this definition, and that definition always requires you to know whether it's positive or negative, the inside of the absolute value. So let's take a look at this. And they've told us something about x. For this particular condition on x, x is any number less than 1. What do you think this expression on the inside is? Okay, if you think of x as any number less than 1, will that expression on the inside always be positive or always negative? If you're not sure, just in your head, pick a number less than 1 and see what happens to that expression on the inside. For example, if I pick 0, I get 0 minus 3, it's negative 3. On the other hand, if I pick minus 5, I get minus 5 minus 3, I get negative 8. So it's negative again. So you can see for these values of x, any value of x less than 1, this thing on the inside is always going to be negative. Okay, so we know that the inside here is always negative, and the goal of absolute value is to make something positive. So we'll need another negative in the front when we drop those absolute values. So there's the answer to that problem. Okay, so we had to introduce this extra negative because this on the inside was always negative. So negative and negative will make it positive. Please make sure you guys do not do this. Students always sometimes do this if they don't understand the definition. They think absolute value makes things positive and they blindly will do this. They will just change all the positive signs to, all the negative signs to positive and give you this back. These two are not the same thing. Okay, and if you don't believe it, you can check it. Let's check it. Let's say x is minus 5, so we get minus 5 minus 3, so we get minus 8. Absolute value of minus 8 is 8. Ouchie, if x was minus 3 minus 5, so you get minus 5 plus 3, you end up with negative 2. Are they the same? No. Okay, so you really have to be careful when you do this, but these two are equivalent. They are the same. Let's test those. We already know if x was minus 5, this was negative 8, right? So let's test this with that. So if x is minus 5, you get minus 5 minus 3, so you get minus 8. Negative and negative is 8, and that's exactly what we had when we just put 8 in here. So let me do that again. You had minus 5 minus 3, we get minus 8. Absolute value of minus 8 is 8. So you can see these two are the same, but we can't just randomly drop negatives when you drop the absolute values. To drop the absolute values, you always need to know what the inside expression is, whether it's positive or negative. If it's negative, you do need an extra negative in the front to make that whole expression positive. Because if you have a negative on the inside, so you have a negative and then the negative on the inside, two negatives will become a positive, which is what absolute value does. It gives you something positive. Let me give you one more of these examples. Let's say if you have this, if I have 2 minus x plus x plus 2, if x is greater than 3. So let's do this. Again, I want to write this expression without absolute values. I have absolute values here and here. So if I'm going to drop those absolute values, write it without absolute values, I need to know the inside, whether it's positive or negative. So let's start with this. For this condition on x, x is any number bigger than 3. What do you think this expression is on the inside, positive or negative? Just in your head, pick some numbers bigger than 3 and test it to see whether it's positive or negative. We don't care about the value, we just want to know whether it's positive or negative. If you pick x as 5 again, 5 is greater than 3, you get 2 minus 5, so you get negative 3. So you know that this is going to be negative. So if this inside is negative and the goal of absolute value is to make that positive, what do we require to happen if we drop those absolute values? So if I write it this 2x minus 2 minus x, then I'll need another negative in the front, because remember what I said, this inside is negative, so you have a negative in here, and negative will become a positive, which is what the goal of absolute value is, to make things positive. So what we want to do is, in this case, is if we're going to drop those absolute values, we need to introduce another negative here, so we get 2 minus x. Over here, let's see what happens. If x is greater than 3, let's pick 5 again in our head. So you get 5 plus 2 is 7, which is a positive number. So this is always positive. Since this is always positive and the goal of absolute value is to make things positive, we really don't need those absolute values in this case. So we just get x plus 2. We can just drop them because you can see that from the definition here. If the inside is positive, if a was a positive number, we just get a back. We don't even need those absolute values. But on the other hand, if a was a negative number, since a is negative, we need another negative in the front to make that whole thing positive. Okay, so that is the answer here to this problem. We wanted to write it without absolute values. We did that. We have no longer any absolute values in that problem. So I'm hoping you guys understood these two problems, because these two problems are a great way to understand that mathematical definition. Okay, so let's go ahead and take a look at how to solve absolute value equations. So we're going to solve equations that have absolute values in them. Okay, so here's an example. Okay, so let's say if I have absolute value of 2x minus 3 is equal to 15. Okay, now let's think about it. Anytime we solve, this is a linear equation, by the way. Anytime we solve an equation, what are we trying to do? If it's linear, we're trying to isolate x by itself, right? Eventually we get rid of all the parentheses. If they're fractions, we get rid of the fractions and we get rid of the parentheses, and then we move all the variable terms on one side, and after we combine them, we want to just isolate the variable itself. And that's exactly what we want to do here. But the only problem here is the variable is inside the absolute values. So you can think of the absolute values as parentheses, sort of. So our first goal should be to get rid of those absolute values. If I can get rid of those absolute values, I can easily solve for x. Okay, so how do I do that? Now in these previous two problems, I gave you some conditions on x which helped us get rid of those absolute values. I told you something about x, because if I hadn't given you this, there's no way I could write this without absolute values. Okay, so we needed that condition. Out here we don't have that condition on x at all. So how do I solve this without absolute values? Well, what I can do is, in this case, since I don't know whether this is positive or negative, because if I know that, then I can drop those absolute values depending upon whether it's positive or negative. But since I don't know that, I'm going to take a look at two cases here. I'm going to first assume that the inside is positive. So let's start with that. If the inside is positive, if this inside of this absolute value is positive, do I even need those absolute values then? No, we don't, so we can just drop them. We get 2x minus 3 is equal to 15, and we know how to solve that. We isolate the variable term, so we get 2x is equal to 18. We move the 3 over, then we divide both sides by 2, so we get x is equal to 9. Okay, so we do that. Now let's assume that this inside term is negative. Okay, because we have to look at two cases, because we don't know what x is, so we can't tell whether this is positive or negative. So if you don't know what it is, if you're not sure, you look at all possibilities. So in this case, we're going to take a look at it if it is negative. If the inside of this absolute value is negative, and if you're going to drop those absolute values according to the definition, we have to introduce another negative on the outside. Okay, remember we talked about that. We need to introduce another negative on the outside. So we have that. So now let's solve this. And this is a linear equation, no absolute values. I want to get rid of those parentheses, so let's distribute the negative first. So we get negative 2x plus 3 is 15. So isolate the variable term, so we get 12. So you divide by negative 2, so we get x is equal to negative 6. So in this case, we got two answers. We got x is equal to 9 and negative 6. Just like in the past, every time we were given an equation, we can always go back and check our answers. So let's go back and do that, because it's always a good idea to do that. Check your answers to make sure you're doing things correctly. Okay, so let's do that. I'll just do it. This is a simple problem, so we can just do it here. We don't need a calculator. X is 9, so we get 2 times 9 is 18, right? Minus 3. 18 minus 3 is 15. What is absolute value of 15? It is just 15, which is what we have. Good. Now let's say negative 6. 2 times negative 6 is negative 12 minus 3. So we get absolute value of minus 15, which is just 15, which is what we have. So you can see both of those answers are valid answers. Okay, let's take a look at another example. So to solve these absolute value problems, okay, your first goal is, since you're solving for x and x is inside the absolute values, your first goal should be to get rid of those absolute values. Okay, and the only way you can do that, since we don't know whether this is, we don't know what x is yet, so we don't know whether this is positive or negative, you have to look at two possibilities. Okay, so let's take a look at a little bit more complicated problem. Let's say that if I have 3 plus absolute value of 2x minus 5 is equal to 3x minus 1. Okay, I want to solve this for x. So let's do that. So the first thing we want to do here is isolate all the x terms on one side and all, is to get rid of the parentheses and the fractions and all of that we've done in the past. So remember what I said, think of absolute value as parentheses. You should try to get rid of those right away if you want to solve for x, because x is inside those absolute values. So since I don't know whether this is positive or negative, because I don't know what x is, I don't know any conditions on x, I'm going to treat it as two separate problems, positive and negative, and then do it. But before I do that, let's clean this up a little bit since we have some extra stuff here. Let me just get the absolute value by itself. It's always a good idea to do that, it makes things faster. So I'm going to move the 3 to the other side, so we get 3x minus 4, because this positive 3, when you move it to the other side, will become negative. Now we can do the two cases. So if this is positive on the inside, I don't need those absolute values, so I just get 2x minus 5 is equal to 3x minus 4. And we can solve this for x. So I'm going to move this to the left, move this to the right. So you get negative 5 plus 4 is equal to 3x minus 2x. So you get minus 1 is equal to x. So there's one solution. Okay. Now before I go that, let's go ahead and check it, might as well since we are here. Okay. So you get x is minus 1. So 2 times minus 1 is what? Negative 2 minus 5. So you get negative 7. So absolute value of negative 7 is 7. So this left hand side is 7. How about this side? 2 times minus 1 is, so we get 2 times minus 1 over here is negative 3. 3 times minus 1 is negative 3. Negative 3 minus 4 is negative 7. So what do we have here? On the left I have a positive 7. Oops. And on the right I have a negative 7. Are they the same? No, they are not. Okay, so in this case the solution doesn't work, so we can ignore that. That's why it's important to go check your solutions. Okay, just don't take what you get for granted. Alright, let's do the left part. So you assume the inside is negative. So if the inside is negative, then when you drop the absolute values, we have to introduce another negative. So let's do that. Minus 2x minus 5 is equal to 3x minus 4. So we distribute the negative to get rid of the parentheses first. You get 2x plus 5 is equal to 3x minus 4. So I'll just rearrange it like before. So I get 5 plus 4 is equal to 3x plus 2x. So you get 9 is equal to 5x. So we get x is equal to 9 over 5. Okay, so let's go ahead and check this. I'm going to show you how to do this on your calculator so you know how to use the absolute value on your calculator. So let's do that. Okay. Alright, so the first thing we need to do is store this into our x like we normally do. So we go 9 divided by 5, store x. Okay. Then what do we need to do? We need to take the absolute value of 2x minus 5. So here's how you do that. The absolute value command or function is in math here. So you go to math, then you go to number. So use the arrow key here and go to number. And the very first thing is ABS for absolute value. So we get absolute value of 2x minus 5 and you close parentheses. Okay, and that's all we have to do there. We just press enter, that gives us the value. Now we do the right hand side, so we get 3x minus 4, we get 1.4, so that is a good answer. So in this case this works. So this time we just got one answer. Okay, so make sure when you do a lot of these problems with equations, you have these nice calculators. Always go back and check your answers just to make sure you're doing things correctly. Okay, let me give you a couple more problems. Let's say that I have absolute value of 4 minus 3x is equal to minus 7. Okay, whenever I give this problem to students, once they understand the previous two problems, they'll just dive into this problem and start working on it. Okay, so let me show you what's wrong with this problem. First, let me dive into it and do it. Okay, so I assume that we have two tracks because I want to solve for x. X is inside the absolute value, so I need to drop those. So when I drop those absolute values, I'll have to look at two cases since I don't know what's on the inside, whether it's positive or negative. So if it's positive on the inside, we just get that back. Okay, so we solve for x here. So we get negative 3x is equal to negative 7 minus 4. Negative 3x is equal to negative 11. X is equal to 11 over 3. Okay, let's check it really quick on our calculators to see if it actually works. Okay, so on. So we have math, get absolute values. Oops, I forgot to store the variable here, didn't I? So we have 11 divided by 3, store x. So we can go math 1. We get 4 minus 3x. We get 7. But we wanted what? Minus 7. So that doesn't work. Okay. So out here we assume that the inside is negative now. So when we drop those absolute values, we'll introduce another negative on the outside to compensate for the negative on the inside. We distribute, get rid of the parentheses first. So we get 3x is equal to negative 7 plus 4. So we get 3x is equal to minus 3. X is equal to minus 1. So this time I'm not going to use the calculator. I'll just do it quick. If x is minus 1, you get negative 3 times negative 1 is positive 3. 4 plus 3 is 7. Absolute value of 7 is 7. That's still not equal to this, so that doesn't work. So according to this, you have no solution, which is the right answer. But why do we have no solution? Well, we didn't even need to go through all this work. We could have recognized that right from up here. Okay, so take a look at it. The goal of absolute value is always what? To give you what kind of a number? A positive number. So on the left hand side, because we have absolute values on the left hand side, you have a positive number on the left hand side, and on the right hand side we have a negative number. Is a positive number ever equal to a negative number? No. So that's not going to happen. So right away when you were given this problem, you didn't even have to do anything here. You could have just ignored all of this because you should have recognized that the absolute value always returns a positive number. It cannot give you a negative number. So you know that this is not possible. Okay. So those are examples of absolute values. Let me do one last one. Let's do one with two absolute values. So we have 2x minus 1 is equal to absolute value of 4x plus 9. Okay. Now, I just want to stress this. Anytime you're working with absolute values with most stuff, just always isolate the absolute value first, like we did over here before you start the problem. It's just easier to work with them. Okay. In this case, we have two absolute values. Now, when I drop these absolute values, I can't assume that this, I can't do this. This is positive, so I get 2x minus 1, and then I'll have absolute value of this. And then if this is negative, I get 2x minus 1 and the absolute value of that, because I'm looking at dropping these absolute values. Then I can't do two more cases, it'll just get crazy. So we can just do it once on together, so we don't have to do so many multiple cases. Sometimes students get carried away and try to do too many multiple cases over here. Okay, so we'll just assume that we're going to drop these absolute values, because in this case both of these absolute value expressions are going to give you a positive number, right? So you don't need to do things twice. Okay, so I'll assume that this is positive. We'll just take a look at this and drop the absolute values on the left. Okay, so we get 2x minus 1 is equal to 4x plus 9, because if the inside is positive we don't need those absolute values. Okay, so we get minus 1 minus 9 is equal to 4x minus 2x, so you get minus 10 is equal to 2x, so we get x is equal to negative 5. Okay, so we end up with x is equal to negative 5. Alright, so now let's check it. So if x is negative 5, 2 times negative 5 is negative 10. Negative 10 minus 1 is negative 11. Absolute value of negative 11 is 11. So we get 11 on the left. 4 times negative 5 is negative 20. Negative 20 plus 9 is negative 11. Absolute value of negative 11 is 11. So this is a good answer. Okay. Now let's assume it's negative. Again, I do not need to assume both of these are negative. On one side we'll just drop the absolute values. And you can see that's what's going to happen. If you look at those 4 cases I was creating, that's what would have happened. So it's better to just worry about one of these absolute values and just ignore the other one. So if this is negative, we need a negative on the outside when we drop those absolute values. So I'm only concentrating on these absolute value. So out here we distribute. We get negative 4x minus 9. We isolate x on one side. So we end up with 6x is equal to negative 8. So you divide by 6. Okay. So we end up with x is equal to negative 4/3. Okay. And if you want to check this, you can open your use your calculators to check it really quick. If x is 4/3, okay, so we go 4 divided by 3, negative 4/3, and you store that into x. Then we take absolute value of 2x minus 1, so you go second math, we go math, and we go 2x minus 1, we get that, and then to the other side we go math, we go 4x plus 9, and we get that. So that works too. Okay, so you can see in this case both of those answers work. So when you have two absolute values, instead of taking care of one absolute value and then taking care of the second like I was doing, like originally I was doing it this way, if you went through all of those steps you're going to get the same two answers. Okay, so instead of doing, okay, let's assume this is positive, so we get 2x minus 1, and then we still have these absolute values, and then you break this down into 2 and then drop these absolute values and do that. And if you do that, it gets too many cases, but in the end it ends up being the same as what I just did when I did the solution. Whenever you have two absolute values, just concentrate on one of them, okay, and then ignore the other one completely. Just drop the other one completely and you'll get the same answer. Okay, so I'm hoping that you understand how to do absolute value equations. The key to absolute value equations is you treat them as two separate problems, because we do not know what the inside is, and to solve an absolute value equations we always have to drop that absolute value, and the only way we can do that is if we treat it as two separate equations, because depending upon whether it's positive or negative you're going to get two solutions. Okay.